The lesson is called Megathrust Earthquakes, and I hope you will enjoy it. So let's start with the basic issue. What it means, megathrust? It means that there is a unusually big earthquake on a very specific region in the world. Let's start with top 5 largest measured instrumentally earthquakes, which were 5 is a very good number. Anyway, so we have the biggest one was in Chile. It was called Biobío or Valvidia earthquake. It happened in 1960, in 22nd of May, which was, so we had the anniversary yesterday. Then there was also, and it has magnitude 9.5, and this was the largest ever measured instrumentally earthquake, which means that there may be some bigger ones in the Earth's history. However, we were able only to measure only those from the beginning of 20th century. So then there was southern Alaska, then there was northern Sumatra. Off the west coast means that it was on the sea. Then was another one which was off coast near the Honshu in Japan, which it was the latest one, so it was 2011, in March 11th, so-called Tohoku Earthquake. And the 5th one was in Kamchatka, Russia, which happened in 1955. In November 4th. So you can see that the span of the biggest 5 is time span is quite big. It's more than 50 years, and in fact it's more than 60 years even. But from the seismological point of view and from the geological point of view, the most interesting is where they happened. So these are the largest earthquake locations. It's more than 5, but let's say it's about 15. And all of them happen in very particular places. So one is very close to the west coast of the Southern America. Then we have the Alaska, Kamchatka part and the islands of Japan. And the last one is near the Asian islands on the Indian Ocean and close to Himalaya border. So what is basically from the geological point of view called borders of the plates in the plate tectonics are those red lines which are visible here. We will come to this, what it really is, the tectonic plates, and why we call this earthquake megathrust. It will be a little bit later, but first we need to know how to measure the earthquake and how to measure the magnitude. Most of those events which I presented at the beginning had the magnitude bigger than 9, which means that they are the biggest measured. So before we measure, we know how to estimate the magnitude, we have to measure it. And we measure it with the device called seismometer, which at the beginning was more called seismograph, which is here on the right part of the slide. And it was just some kind of pendulum attached to the frame. And there was a moving cylinder with the paper or other kind of medium that can be some kind that can record the vibrations of the ground. And when the wave came, this pendulum has a very big mass, and it was almost not moving at all, while all the other parts were moving. So the moving block with the paper just was turning around, caused somehow that the pen was zigzagging the seismic waves on the paper. It was the first seismometers were invented in last years of 19th century, and the biggest improvement, then there was some kind of mechanical improvement at the beginning of 20th century. But since then we have seismometers which look less spectacular. They are just some kind of cans with a huge amount of electronics inside, and they can measure the vibration of the ground on 3 axes. The first one is the vertical one, and there are 2 horizontal axes which are aligned to the main geographical directions. So the one axis is north-south and is pointed towards north, and the second one is east-west and it's pointed towards east. So in such a setup we can measure the vibration and all the shaking in the 3-dimensional way. So when we measure it, we can then try to calculate how big was the magnitude. In fact, at the beginning the magnitude was measured as it was proportional to the distance from the location of the earthquake and how big was the amplitude of the measured waves. During the time this changed a little bit, because in the beginning this measurement of the amplitude didn't allow us to have some kind of physical meaning. And in fact, moment magnitude, which was invented in the late 70s by the Hiro Kanamori and Tom Hanks, sorry, not Tom, it wasn't this actor, it was seismologist from the United States. They figured out that there is some kind of thing of the unit or the way how to connect the magnitude with some physical parameters, and it was called seismic moment. Seismic moment is the area of the rupture, how much the 2 blocks of the fault moved, and some parameters, parameter μ, which means that there is a shear modulus which is connected to how dense are the rocks and how stiff they are. And from that we can go to the moment magnitude, which is logarithmically connected with the seismic moment, and we can calculate from this amplitude of vibration and knowing how far we are from the source, which means that first we have to locate the earthquake with these recordings, and then we can at least estimate the moment magnitude with seismic moment, and then we can also say something about how big was this part of the rupture, which means so how big parts of the rock masses were moving to each other. So when we have the measurement, and then we can talk about the plate tectonics, which means that we measure and locate the events which are here, and they are very big, and they connect to those boundaries which we can see here. So the first biggest, the most occupied by the big earthquakes boundary, where we measure the biggest ones, is the boundary between the South American plate and Nazca plate. And we can see from the arrows that the Nazca plate is diving down under the South American plate, which means that there is a subduction zone. So the ocean floor is subducting under the continental block, which is forming the South American continent. The second group of the biggest events are in the boundary which is between North American plate and Pacific plate. This is a little bit more complicated because there are some places where there is transform. These two plates are moving, sliding, like a little bit. Two cars that are too close to each other and they are just sliding one to each other. But in the other places on the north, when we have Alaska and Kamchatka, there is also subduction zone when the Pacific plate is subducting under the North American plate. And the third group is more to the south, close to the Japan trench, when we have the a little bit more complicated situation because we have small Filipino plate, which is playing some kind of role in the seismogenic process. But then we have also Pacific plate that is subducting under the some kind of rest part of the North American plate here. And the Eurasian plate is also playing some kind of role in this process. So we have quite complicated situation. On the other hand, the last part, which is connected with Sumatra and Himalayan earthquakes, we can see here that we have the Indian plate, and then we can connect it with the uplift of the Himalayan, that there can be a huge earthquakes because of the collision of two continental blocks. However, in case of Sumatra, we have also the subducting plate of the Australian plate under the Eurasian plate. So this is there was a lot of information now to you about the geology and the tectonic plates. However, from the seismological point of view, those plates play a crucial role in so-called seismogenic process. So it means that if there will be no plate tectonics, probably we will not encounter any earthquakes. On the other hand, it means that there will be no movement of the plates, and there will be and our planet will look more like Mars than the Earth. And as you probably already know, Mars is not habited by any more complicated forms of life. So this plate tectonics and earthquakes are somehow connected to our existence on the planet. And when we look further, I will try to describe you these 5 biggest events, which were Megathrust earthquakes, which means that there was a the earthquake was very big, so magnitude over 9 and bigger. But what it means Megathrust? It means that the rupture was enormously high. So in the area of Kamchatka and this part of the world, this was the biggest earthquake in this area. It was in 1955 in November 4th, and how big was the rupture shows this right part where there are patches of the sliding fault. So the hanging wall was moving up at this distance, and this distance is much bigger than several hundred kilometers. There was also, with the Megathrust earthquake, there are also tsunamis generated usually, and the tsunami waves in case of this earthquake was bigger than 12 meters and caused significant damages in Severokurilsk, which is the town in Kamchatka Peninsula. And we can see how far from the lines here we can see how far the earthquake was felt. So it was also very big distance from the trench, which was several hundred kilometers apart of the trench that the earthquake was felt. There are the earthquakes occurring there very often, so it's not something unusual that there is an earthquake, but the earthquakes of such big value, of such big magnitude, is happening very, very rare. So it means that the magnitude 9 happened once in almost more than 100 years. We don't have any information about significantly bigger in the history or similar earthquakes there from the last 200 years almost. Then the latest Megathrust earthquake was the Tohoku earthquake from 2011, from March 11th. It has magnitude 9.1, and it is well known that this earthquake caused very big damages and caused a huge catastrophe connected with tsunami. So the tsunami was very big. The waves were bigger than 10 meters high, and the Japanese government and the Japanese civil protection haven't been prepared for such big waves. The structures should survive 7 to 8 meters because from the historical events there was only such a big height of the waves denoted and reported. Nevertheless, it was 20,000 casualties because of the tsunami, and almost none of the people died because of the shaking. So all the structures, all the buildings were surviving the shaking. However, people and living close to the shore had not chance to escape, and there was a lot of people. So 20,000 casualties is a big number, which is a little bit sad. However, from the seismological point of view, this was quite big earthquake. The rupture was bigger than 600 kilometers. We can see here what was the scenario of the event, and we can see that the biggest slip, so the biggest movement of one part of the fault against another, was more than 50 meters. So it means that there is if the one-story building is about 3 meters, so it's about 20 floor building moved in a couple of seconds up on the fault plane, which means that there is a quite huge movement, and it is more or less 600 kilometers of the length that is moving up on the sea floor. So that's why the huge tsunami is created. You can see also how far it was felt. So almost whole Japan felt this event, and it is not something unusual because these megathrust earthquakes are usually felt very, very widely. The next slide is showing how you can imagine the fault plane and the megathrust earthquake generation. So at the bottom there are effects of the tsunami usually generated because of the earthquake. So we have the rupture zone here, and this plate, which is above which is continental plate, just moved up towards the Pacific plate, so it created a huge tsunami wave. And this is at the middle. There is a view of how big the waves were crashing against the coast in one place near the Tohoku. So effect was devastating. So some towns were demolished totally. The big sea carriers were swept into the inland. And the activity near this part was huge, so the aftershock sequence lasted for more than 1 year. And this zone is still active, but of course it's considered that most of the power stored, most of the deformation stored before this huge event was released during the Tohoku Megathrust Earthquake. The next one was the Sumatra, which happened in the second day of the Christmas vacation in 2004, and it has magnitude 9.1, and it also generated tsunami. It is very common that Megathrust earthquakes usually cause tsunamis. All of them which are known now cause tsunamis, and these tsunami waves were even bigger than in case of Japan, because the waves have up to 30 meters height, and because it was close to the small islands, a lot of small islands in Sumatra and in this Bay of Bengal, and close to the southeastern Asia, southwestern Asia. It happened much more. It caused much more casualties. It was almost 300,000 of the casualties, while in case of Japan it was 20,000. So this was huge, also huge catastrophe, and a lot of tourists that were visiting during the Christmas vacation those parts of the world were the casualties. However, also the local inhabitants died due to the so high tsunamis. And you can see that on the left we have how far it was felt. So all the Sumatra part was moving it was very widely felt in this part, and then also up to the Thailand it was felt as a significant shaking. And it is worth to mention that the shaking connected with such big earthquakes can be felt for several seconds up to minutes. So in fact, it's a very long-lasting process. It depends also from how far we are from the earthquake, but it is very the shaking is very long, very big usually, and it's not nice at all. In this case, we had here we see the fault model, and the fault model shows us that the movement of the one plate against another had over 1,000 kilometers of the length, and the movement of the one part of the hanging wall of the fault against the foot wall was quite big, also several tens of meters in one part. It is worth to mention that it is not whole block moving at once uniformly. So some parts of this of the fault plane are moving much faster and much bigger, and the other ones were moving slower. So it's not the process that there is a whole 1,000-kilometer block moving at once, but some parts start, the other didn't start it, then they start, the other parts stop, and it can last a significant time. It can be from several seconds up to in some cases it may be up to minutes, but it's not so often. Yeah, so this is another view of the tsunami in Sumatra region. You can see how big it was. So the waves were crashing against the shore at the height which was bigger than the trees that we can see there. So there are palm trees which are quite big. And if you have tsunami waves in some parts which are 30 meters height, it means that there is it will flood inland very much. The second biggest earthquake ever measured by the seismologists was the Megathrust Earthquake from Alaska from 1964, from the 28th of March. It has magnitude 9.2. It was called Good Friday earthquake. Why it was called like that? Because it happened in the Good Friday in '64, and it was because the shaking was felt in almost whole Alaska, and even farther, as we can see here. It was considered as not as at the beginning as the earthquake, but the people start to fear that there is a beginning of the nuclear war, that somebody detoned, exploded, and attacked the USA with so Russians attacked the USA with the nuclear weapons. However, so people start to panic a little in some places, but it was mistake, fortunately, and it was natural phenomenon which caused the rupture was about more than 800 kilometers length, and the strong tremors were felt for over 5 minutes. So with the lasting of the rupture was at least so long. So it means that there was a very long movement, very long lasting movement of the plates, releasing the energy as in form of the seismic waves. So tremors were, in this case, was felt on area of 1.3 million square kilometers, but it has only 131 casualties, mostly killed by effects connected with the shaking, not exactly by shaking or collapsing of the buildings. There was a lot of landslides, a lot of such derailed railroads, and some strange bending of the Earth's surface. So there was about the surface effects were enormous. So we can see that there were 10 meters of ground elevation in Kodiak, and up to 3 meters subsidence of the and change of the Prince William Bay shoreline. So the shoreline moved 3.4 kilometers inland, and it caused flooding of the Portage town. So you can see that there was a huge area affected by the earthquake, and these effects were not only connected to people that felt it, but also the part of the landscape was highly affected. So the 10-meter elevation is easily visible, so it's 3-floor building almost, and 3.3 meters subsidence is also visible, which was at least at the 3.4 kilometers. So it is quite huge area. The effects can be visible here. So this is this uplift of the Kodiak, where the seafloor went up to the surface, and we have the sea, which is not anymore in the place where it was before the earthquake. So there is also some collapsed buildings and damaged roads, which is usual sight in case of big events. And this is the third picture, shows how it looked when we look from the aerial view on the part of the Alaska. And the biggest earthquake happened in 1964 on 22nd of May, and it happened in Chile. and has magnitude 9.5, and up to now it's the biggest earthquake. It doesn't mean that there are no bigger possible. They are, but this was the biggest measured. You can see that the shaking was felt almost at the whole width of the Southern American continent. These tremors lasted for 10 minutes, and the rupture length was 800 kilometers, so it means that it was smaller. The length of the rupture was smaller than in case of Sumatra, for example, but it lasted much longer, so you can assume that there was a bigger movement on the fault plane. So it also generated tsunami, and the tsunami waves were up to 25 meters, measured in Chilean coast. It caused 1,665 casualties, mainly because of the tsunami and local collapses of the houses. And the effects were also quite enormous, and you can see that most of the buildings were not used. You cannot inhabit them anymore after this earthquake. There were roads which were damaged significantly and needs huge reparation. And this part of the world is considered as one of the most active, but it is the most, let's say, subduction zone, which is very spectacular. So we have the huge subducting Nazca plate is subducting quite fast. It's up to 12 millimeters per year, as far as I can see, and it's subducting very fast. There is connected with that the Andes uplift, which are quite huge mountains, and of course the earthquakes happen there very often, and they are usually very big. So at least in the last several years, let's say 10 years, there were at least 2 earthquakes which were bigger than magnitude 7. And one of them was 8.8. It was in 2010, and there was also some events, a multiple number of events which has magnitude 6 and more. So the basic question is how megathrust earthquakes are formed. I partially described this, but when we look at it from the geological point of view and from the seismological point of view, first we need to have subducting plate. It is worth to note that this scale is highly exaggerated because the subduction angle is much lower than this. What you can see here. So this plate is slowly subducting, diving under the continental plate, but in the same time it is building a deformation of this part, and also connected with this part. And so we have the deformations which are more and more bigger and bigger. So we have a part of the subducting zone which is usually very slowly subducting. So it means very slowly in the terms of our understanding. So understanding that cars are moving several kilometers, several tens kilometers per hour. So it's very slowly that you have about 1 or 3 centimeters per year. But in fact, in such a big amount of rocks, such a big mass, it's a huge movement, and it causes huge deformation and storing a lot of energy there. So then of course, if it would go smoothly, and there were no traction or very slow traction here, it will allow this subducting zone without any harm subduct to down underneath, and nothing will happen. But there is a traction, and the tension rises, and when the tension is bigger, when the energy stored there is bigger than the traction, the rupture starts. So it means that there is a, like on the low right picture, there is a hypocenter, so there is a point when it starts, and it starts to move towards the surface, actually causing also some breakage perpendicular to the fault surface. And of course, there is also high, very big movement of this deformation down or up. It depends on which part of the zone we are, of the surface of the bottom of the sea or the surface of the land, and it causes huge upward movement of the water. So then we have tsunami, and this is very crucial part, that in case of the megathrust earthquakes, we have always a huge rupture zone, which is several tens of kilometers. They are also at the plate boundaries of the two plates, which one has to subduct under the ocean plate, has to subduct under, so dive somehow under the continental one, and it causes shaking which can last up to several minutes. And these megathrust earthquakes are formed in these boundaries. Usually, the 5 ones which I show you are the most significant examples of that phenomenon. So now the presentation is almost over. So if you have any questions, just write it on the chat, and I will try to answer them as good as I'm able to do it. And thank you for the attention, and I hope you enjoyed the lessons.